Hello, hello, and welcome to this video. In this video, we are going to cover smart pointers, which is a very important and a central concept in C++, particularly modern C++. There are three smart pointers which I believe came in C++11. Namely, they are unique PTR, shared PTR, and weak PTR. So if you have watched my Rust videos, you would know that box is example of a unique PTR. Then we have RCFL, which is like shared PTR. And finally, there is weak PTR also in Rust. So analogous to that, C++ also has these three things. If you watched my previous C++ video, I have said it several times that you should never use new in modern C++. There are very extreme cases when you really need new. In general, you don't need new. So to begin with, I'll show you my main function. Main function is smart point demonstration. We have unique PTR example function call. So let's look at unique PTR example function. So this is unique PTR example. Now unique PTR is like box of Rust. There can be only one owner at a time. There cannot be two owners. The ownership you transfer by using std_move. In Rust, it is simply by assignment you can do that. So we take a class employee and we make a unique PTR, observe the syntax. Okay. The make unique and unique PTR, those things live in memory header file. Vector and strings are used for other things here. An IO string is for IO. So let's look at the class employee. It has one data member name, and the constructor constructs the object using initializer list as well as prints the message. And then destructor prints another message. Work prints if the employee is working, and get names gives us the name of the employee. In unique PTR, you observe the syntax here. This is how we make an object, or rather unique PTR we make. Okay. So the constructor goes in double quotes here. We name argument. The left hand side is the typical generic what we call class syntax. So unique PTR, and then within angle brackets you have employee e1 is equal to make unique employee Alice. Once this PTR is ready, we can invoke what from this, and we print Alice is working, I believe. Yeah, Alice is working. Then how do you transfer the ownership? You don't do e2 is equal to e1. That will be an error. Okay. What you do is you make the std_move call on e1 and it gets moved to e2. And we have seen how the move operator works in operator overloading. We have already seen that. At this moment, e1 will become invalid, and the not test case will pass and will say that e1 no longer owns the object. Then e2 work, and it will still be Alice is working, and then we leave the function. Okay. So let's run this program and see this in action. Okay. So G++ minus eval minus W error minus std is equal to C++26 minus pedantic. Our typical features for G++, and then we run this. So first is employee Alice will be constructed. Then Alice is working. This is E1. Then we transfer the ownership, and then E1 no longer objects the object. Then this is invoked on E2. Then we are leaving the example function, and finally employee Alice is destroyed, and eventually program is finished. So that was about the unique PTR. Now, as you saw, we can have only one ownership, or rather one owner. This causes issues in certain cases. For example, you take the case of doubly linked list. A particular node will point in forward as well as backward direction, in both directions. Same can happen in graphs. Okay. Even in this example, you will see we will introduce a class department. So now employee has a department, and department has employees. So that is a circular link. Now in circular links, problem is that destruction won't happen because the links are valid. So we have shared a PTR example here. Let me see, where did I put the department class? Okay, not here. This is employee class and department is here. Okay, we'll see that. Okay. So now we look at the shared PTR example. Okay. The shared PTR solves the same problem which RCFSL does in Rust. Okay. Shared PTR has multiple owners. Similarly, you can have, in general, whatever pointer we make using new pointer, we have like shared PTR. You can have multiple copies. So it is a ref counted PTR. It maintains a reference count and object is destroyed when the count becomes 0. So now the syntax is similar to unique PTR. We call make shared instead of make unique. At this moment, if you compute the use count of this, it will be 1, right? And then we have another shared PTR, we make a copy. So the ref count will be 2. And this team lead has the copy of manager. So the name is Bob. Okay, Bob at this moment is both team lead as well as manager. So this team lead work will also print Bob is working. Then we create another one, developer. So use count should be 3 here. And then Bob will work. Then developer will be destroyed, ref count will be decreased, then team lead will be destroyed, manager count will be decreased, and so on. Okay, so we compile this again and we run this. So when Bob was constructed, that is manager, ref count was 2. When it was copied to team lead, ref count became 3. And when it was copied to developer, ref count became 3. And as we saw, when we leave the scope, the counters are decreased. And finally, when we leave the function, the employee Bob, that is the shared PTR, that was destroyed. Okay. So we know that this will cause problem if there are two smart pointers pointing to each other, okay, or other shared pointers pointing to each other. That will cause a problem. It will never be, the ref count will never be 0. So we have a weak PTR example here. So consider a class department, okay? Right. So employee node, all right, from here. So we have a class department for our declaration because employee nodes need that. So it holds the department as a weak PTR. And we have the constructor and destructors are there, and then we have for department. Okay. Now we have department, it has a name, it keeps the employees in a vector of shared PTR. The department constructor is there and the destructors are there. Then we have employee node show department. So at this moment, if you see, we take a lock on the department, okay, of employee node. So this lock, when you take on a weak PTR, we can actually use it. So at this moment, we can get department name of the department. Okay. And finally, when the lock is gone, department no longer exists if it is destroyed. So with PTR example is given here, you create two make shared objects. One is department, another is employee. Okay. And then in the vector which we had in the department, we put the employees. Okay. And finally, we set the department of employee to department. And then we look at the ref count, we say show department, then we reset the department, we say department dot reset, and we show the department again, and we do that. So reset department, reset function, it might be below it, reset. Okay, so it is a call library call, okay? All right, I forgot that. So we again compile this and we run this. You see that first department engineering was constructed, employee node Charlie was constructed, then ref count was 1. Charlie belongs to department engineering. We reset the department engineering is destroyed, department no longer exists, and then we use the function, and at that moment employee node Charlie was destroyed. So that's how the program works, and that is how you can use the 3 smart pointers: unique PTR, shared PTR, and weak PTR. So weak PTRs are needed only when you have two different pointers pointing to each other, okay, or having the connectivity to each other. For example, W-linked list or graph kind of data structures. In real life, there can be lots of things which can show this kind of relationship. So unless there is connectivity back and forth, you don't need weak PTR. Ideally, if you want to look at design questions or other choices, then you should prefer unique PTR all the time. If you can do unique PTR or rather use unique PTR, very good. So unique PTR, if you want to share the pointers, you should use shared PTR. But be careful that two different classes do not hold the references of the each other's shared PTR. And if they do, by design or by requirement, then make sure you use one containing the weak PTR of the other rather than both containing the shared PTR. Okay. And ideally, you should never use new. In certain cases, you will need new operator. You will explore that much later. Okay. There are certain things you can do with new operator which you can't do that easily with unique PTR, shared PTR, and with PTR. Certain things are possible, and we will learn those for the sake of completion. But for, I would say, 99% of the code, you don't need to do raw allocation of new. And as you have seen, we don't have a corresponding delete all on the pointers. Okay? The reason is that the destructor calls are automatic for these two types of pointers. Okay? So with this, I will end this video here. And in the next video, we will learn about friend classes and friend functions. Right? That is something I have ignored till now. I could have covered that earlier, but I thought I will do that after this smart point of discussion. Friend classes and friend functions can be very helpful in certain cases, and it depends on the, of course, the design and the requirement. But yes, in certain cases, they are very helpful. So with this, I will end this video here. I hope that you have enjoyed this video and found it useful. So we meet again after 4 days. That is, if my routine does not get disturbed. So I'll take my leave here, and you keep learning and have a great day. So I'll say sayonara to you, and I'll see you in the next one. Bye.